Current vision language models struggle hard with multi-video event understanding. Feed them long, heterogeneous video collections, and they exhaust their context window or latch onto visually salient noise, missing sparse evidence like broadcast graphics, subtitles, or scoreboards. Trace fixes this with a strict ground-before-reasoning paradigm. It completely separates perception from reasoning. First, it runs lightweight object detection via YALV 12 and OCR across sampled frames, building a fully text-serializable timeline of detected objects and on-screen text. A text-only LLM then takes over, aligning this structured timeline with your query and persona to pinpoint exactly which timestamps matter. This text-based localization is fast, deterministic, and vision-free. Next, Trace uses a hybrid frame selection strategy. It keeps uniformly sampled frames for broad context, but injects the guidance-targeted keyframes directly into the LVLM's input. Crucially, it passes explicit timestamps as positional metadata, preserving correct temporal spacing in the model's rotary position, embeddings, so the visual and textual axes stay perfectly aligned. The LVLM then generates factual claims conditioned on these frames, the grounding summaries, and ASR transcripts, with strict instructions to cross-validate annotations and prefer concrete facts over vague paraphrasing. Finally, claims from multiple videos are consolidated using embedding-based clustering and LLM verification, propagating citations across sources. The results are stark. On the MAGMaR 2026 benchmark, Trace pushes macro-average MiRAGE F1, which measures both factual completeness and citation accuracy, from 0.705 to 0.811 over a strong 30B baseline, with citation recall jumping from 0.44 to 0.628. That massive recall gain proves that structured perception-based grounding actually forces models to cite the full evidence base, instead of just the most salient clip. Trace shows that scaling context windows isn't the answer to long video reasoning. By routing attention through lightweight, text-serializable grounding signals first, we get models that don't just watch videos, but actually read the room, cite their sources, and generate verifiable claims. If you're working on multimodal retrieval or event understanding, this pipeline is worth deep diving.